Okay, the time's come for us to talk about the next part of the equation. So, in the illustration that we had over here earlier in the previous video, we received the ARP request. Here, and remember that ARP request actually went out all of these interfaces, but since host 4 is the device that actually does have that IP address, 192.168.0.4, what he's going to do is he's going to formulate an ARP reply. Now let's walk through this process over here. So now we have our switch. We have our interfaces. We have our host. And this host has received the ARP reply. The ARP request. Now I want to look at this ARP request. This ARP request has arrived with a source MAC address of MAC1, the MAC address of host 1. And we know that this guy down here has a MAC address of MAC2, and it was destined to the MAC address, and I'll go ahead and write it all out one more time, of all Fs. One, two, three, four, five, 6. So 6 bytes. Now, when it comes time for this host to reply, it's interesting because I know the source MAC address that it came into, so that's actually what I'm going to make the destination MAC address. So when I send the ARP reply, the source MAC address, it's a layer 2 frame. It's going to be MAC2. The destination MAC address, the device that I want to respond to, is going to be the source MAC address of the ARP request. So I'm going to reply to MAC1. So as you can see, I now have everything that I need to be able to build this layer 2 frame in this switch. And it's also important to understand that I still have that database that we were talking about. And in that database, MAC1 was reachable out of interface 1, and MAC2 was reachable out of interface 4. And as the ARP request came in, I placed an entry in here that said MAC1 is reachable out of interface 1. Didn't pay attention to the all Fs because that was the destination MAC address, and we don't learn destination MAC values, nor would I ever put a broadcast or a flood MAC address in the CAM table. And remember, we're talking about this for a specific VLAN, VLAN 1, and we'll get into VLANs in some detail a little bit later. And then it is not until this ARP reply gets sent that the switch learns about MAC address 2, and it makes entry that it is reachable via MAC address 2. And then ultimately what's going to end up happening is the system says, well, this is destined to MAC address 1. So how do I get this frame to MAC address 1? Well, when I look at MAC address 1, it's in my table, and it says to just simply send it out of this single interface, which is going to be Ethernet 1. What you just saw is the principle of forwarding. So, switches flood when they don't know the destination. So when the destination is unknown, they have to employ a concept called flooding. It's not very efficient. It is very verbose, which means there's a lot of talking that's going on from the devices. But ultimately, at the end of the day, by sending information out of every available interface, the assumption is that I definitely should be able to at least reach the device that I need to resolve. And a perfect example of a protocol that is flooded is going to be the ARP request. However, the ARP reply has sufficient information to actually be forwarded, because I know the source because it's coming from me, and I know the destination because it was learned as a part of the MAC address learning process that runs inside of the switch as part of its integrated intelligence. So again, this is a pretty big pill to swallow as far as building things out, but ultimately what ends up happening here is as a result of receiving the ARP reply, the ARP reply says, well, the IP address of 192.168.0.4, host 4, is actually attached to MAC address 2, and now the system now knows how to put things together, and what will end up happening is it actually goes in here and writes in MAC 2, and now I have everything that I need to be able to forward the data, which means I can remove my original payload, my original frame, out of memory and then send it. Now, a lot of you have probably seen output like this, where you type ping and you ping an IP address 192.168.0.4, and you want to see, obviously we want to see 5 ICMP echo replies. So you want to see 5 exclamation points when it comes to Cisco. That tells you that you sent 5 packets and all 5 packets were delivered. However, a lot of time, the very, very first time that you ever execute one of these pings, sometimes you get a situation where you have a dot and you have 3 or 4. So you have 2 dots and 3 exclamation points. Sometimes you have a single dot and 4 exclamation points. And what this dot represents is the fact that the system dropped that particular packet that it's sending via ICMP as a direct result of the amount of time that the original payload had to stay in the parking space, in the buffered memory, before I could resolve the destination MAC address. So sometimes that happens, but it normally happens only one time. So immediately after typing this ping again, that dot goes away. So just understand that this does take time, and it is an inherent behavior of our Ethernet infrastructure, and it's inherited from iOS all the way into data center. There's not much that we're going to be able to do about it because, quite simply, Ethernet is a standard. Cisco didn't invent it, Cisco just merely implemented it, and we all rely on this idea of address resolution protocol in order to be able to resolve the destination MAC addresses in our infrastructure. And you can also see it also pre-drives the formation of the intelligence that's embedded in our switches and devices. So with that being said, I'm going to go ahead and wrap here, and what I'm going to do is I'm going to come back and have a little summarization of what we talked about, and then that'll wrap up this lesson. And then what we're going to do is we're going to move into some of the more advanced functions and capabilities of the devices that operate at layer 2 of the OSI model. Specifically, I'm talking about switches, of which all Nexus devices are switches. They may have layer 3 routing capabilities, but out of the box, they're all going to be high-speed switches operating at line rate. I'm Terry Vinson, and I'd like to thank you for learning Data Center with me.